Oh my God, this guy is a genius. A giant industrial gear originally priced at $100,000 was made in his workshop for just $1,000. How did they manage that? Since they needed to craft such a large gear and didn't have a sandbox of that size for molding, they dug a hole right in the ground. When the hole reached a certain depth, they placed a fixed gear mold inside to check the depth. Once they ensured the depth met the molding requirements, they covered the entire bottom with mixed sand. Then they placed the inner mold on top of the sand, using pressure from the inner mold to shape the sand. They also filled the edges with sand while simultaneously smoothing the surface with a scraper to ensure a tight fit between the mold cover and the bottom, preventing molten iron from leaking out directly from the gaps during pouring. After poking ventilation holes around, they created a frame for the mold cover with iron frames of equal size. They used red bricks to mark the pouring and observation holes in advance. Once they tightly packed the filled sand, they removed the bricks, leaving the pouring hole ready. After hoisting the cover with the inner mold, they placed preformed sand blocks at the bottom. The spacing between these blocks and the center needed careful measurement. Once confirmed, the just-made mold cover needed to fit snugly against the ground for sealing, filling any gaps in the edges with sand. To prevent the cover from shifting during pouring, solid weights were used to press it down. Meanwhile, the master prepared the raw materials for pouring. In the early stages of furnace melting, they first poured in smaller volumes of scrap iron, which melts more easily. After the furnace temperature rose, they switched to larger volumes of scrap iron. After an hour of heating, they used a crane to catch the molten iron with a ladle. The operator carefully controlled the crane to pour it into the mold's inlet. After cooling overnight, the master could demold the gear. The sand, hardened by high temperatures, had to be completely broken down. Since the gear had deep grooves inside, when a hammer wasn't enough, they used an electric chisel to remove the sand covering the surface. The rough castings also needed to be cut with oxyacetylene. The iron blocks protruding above the gear were formed during pouring and had to be completely cut off. Components cast with sand molding have many burrs, so they used large lathe tools to completely cut off a layer of the casting's entire surface. Then, they measured the outer diameter of the gear with large calipers. After ensuring the accuracy of the data, they carefully trimmed and cut the surface. After 3 hours of machining, they used calipers to measure the processed data. Once the data was confirmed to be qualified, the industrial gear made from melted scrap iron was finally completed.